Good evening. Welcome to Cornerstone Home Inspector Education Center. Tonight we have Radon and Air and Water, presented by one of our owners, Scott Montefiore. It's going to be very informative. Scott's got a lot to talk about, and we have a lot of slides to get through. If you have any questions, feel free to break in or just type into the chat bot. Upcoming webinars, January 5th for Connecticut inspectors. January 5th and 6th, we have our Connecticut Law Seminar, and that will be a 2-day event. And then January 20th, mobile home. So I will hand it over to Scott. Take it away.
Thanks, Jim. I appreciate it. And just so you know, most of you guys know me. Some that don't know me, I've been inspecting since 2003. And I just want to give a shout out to Stan Bajerski, who got me into this business. And I have a lot of respect for Stan.
I'm sorry.
He's a great inspector. We've worked together for many years. And he even did radon. We got into the radon business in 2006. So I've been inspecting since 2003. I've been doing radon mitigation, air, water since 2006. And Stan and I both can say we went to school to get certified out in Rutgers. And that was much more difficult than we thought it was. We thought we were going to go out there and hang out and have a good time. And it was a really challenging program to get certified. So what we're going to talk about tonight, just to let you know, what is radon, how it enters the home, health effects, and testing and mitigation. And I'm going to hopefully, as a home inspector, hopefully give you guys some tips. So when you're out there inspecting, you come across these systems, whether they're working or not working, what you could look for, that hopefully you can tell your client, and hopefully you can get that system fixed, or they get a credit to have it fixed, or if you have to have a system put in. State standards for New York, New Jersey, Connecticut, Mass, Rhode Island. The home inspection standards of practice do not require you to perform radon testing, and in most cases, they explicitly exclude radon environmental testing from what's covered in a standard home inspection. Radon is treated as optional, separate service governed by other rules or programs. So, I mean, you're not required. In Connecticut, you're not required. I got to be honest with you. Some people don't test. Some people test. Some people call up afterwards and said, I should have tested, my levels were high. So I would encourage you to tell your clients to test and a lot of times they don't even know what radon is. Today, a lot has changed. People are on the internet. They're a little more savvy. Testing during a real estate transaction, the buyer requests the radon test. Radon testing is not required by state home inspection SOPs, but is very commonly requested by buyers during the inspection period. It is typically added service, and you guys, and the prices vary. My price is my price. Everybody else, if I have a price for when I go to the house, if somebody calls me up as a radon mitigator and I test, I have to go there. I'm not there doing the inspection, so my price may be a little less when I'm inspecting because I only have to go back once. Fees generally $100 to $175. It can go up from there. Closed house conditions must be established to ensure accuracy. Closed home conditions are required. So the windows and doors have to be closed 12 hours prior. One thing I will say is we hear all the time from agents, they say, well, the house has been closed up. That's why the levels were high. So, if the house has been closed up for 6 months, a year, 2 years, it doesn't matter because radon has a half-life of about 4 days. So even if I tell the agent, open up everything, open the windows, the doors, if you want to air out the whole house, close it up 12 hours prior to me testing. And I guarantee you the levels are probably going to be the same. No house is completely airtight. There's always air exchange, windows leak, sills leak. There is always air in and air out, and the radon is decaying. So as long as they're closed up 12 hours, they must remain closed. And we'll talk about that later. If it's 90 degrees and there's a little old lady there, if you're testing and you have to leave the windows open, just make note of that when you test. I mean, it's not following EPA protocol, but certainly you don't want the poor lady to die of heat exhaustion. No house fans, attic fans, HRVs, ERVs. We can talk about that as well. They even talk about vacuuming and all that. I mean, it's the real world testing, so do the best you can to try to follow the EPA protocol. There is something that guys are doing, and I'll talk about that later. AC and heating, normal operation, and this is universal and comes from EPA, ANSI, and ARS protocols. I'm National Radon Safety Board. I'm certified in mitigation, not licensed, certified in mitigation and in testing. Approved testing device is placed in the lowest livable level. It used to be lowest level suitable for occupancy. The test device is placed in the lowest level suitable for occupancy. Finished or unfinished. Now, here's the thing about basements. If I can stand up, we've all done an inspection. If you have to duck over a duck or duck under a duck and go up and you still can stand up, that to me is a basement. If you have to walk around and you're bent over and you're, you know, maybe it's only 48 inches, to me, that's considered a crawl space. And, you know, we're doing a real estate transaction. We're not doing it for a homeowner who called you to test, just to test the home. There are times when a homeowner says, I never go in that basement. I don't care, test on the first floor. Most of the time we're going to test in the basement, whether it's finished or unfinished. Crawl spaces, we don't test in crawl spaces at all. Although I've seen people do it. I've seen people test, again, if the person is only 5'2" and the basement is a little bit shorter than me, I'm 6 feet, you know, you might want to test down there. I would always test in that basement, because if you don't, the next person that purchases it may test, and that's the lowest level that they can actually occupy. They can put a gym in there. They could put a, you know, they can put a workbench. And these are some of the protocols. It has to be 3 feet from a window, a door opening. Do the best you can. Sometimes there's a table there and the table is almost 3 feet away. 3 feet from an opening for drafts. If it's just an exterior wall, about a foot, and at least 20 inches off the floor. Okay, we put them higher. Sometimes they're hung. And if it's a continuous monitor, you know, we have a little stands for it. And each device should be about 4 inches apart. And why we have 2 devices versus 1 device, and then the continuous monitor. If you are doing a real estate transaction, if you're going to use a continuous monitor, you only need the monitor, and that monitor should be calibrated once a year. You should have the documentation for that to show that it's calibrated. If it is EPERMs, if it's charcoal canisters, you have to have 2. And there's a reason for that. The reason you have to have 2 devices is because you're doing 2 simultaneous tests, right? If one test comes, let's use this as an example. If one test comes back, I was going to jump on this at the end. Let's say one test comes back a 3 and one test comes back a 6. The lab is going to flag it and say that it's twice the lower number, retest. So if you have 3 pica curies and 6 above 4, 3 is below, the lab is going to flag and say the relative percent difference is twice the lower number. That's not something, I mean, the lab, if you're using a lab, they're gonna bring that up to you. And if I've had ones that are off, if you have the relative percent difference is the difference between the 2 results, right? The 2 results, the difference, right? If it's 3 pica curies and 6, the relative, or the difference between the 2 is 3. And then you average the difference between the 2, and then you average the 2, and then you divide that, and then you multiply it by 100, and that will give you the relative percent difference. So just talking about that real quick, let me give you an example. We talked about if it's a 3 or a 6, retest. If both levels are less than 4, and I'll give you an example. If it's a 3 pica curies and 1 pica curies, they're still below 4. Okay. The relative percent difference is roughly about 100. It's not roughly, I calculated it. It's about 100. That's greater than 67%. I'm not going to get too technical on this, so I'm going to move along. 67, if it's less than 4 and the relative percent difference is greater than 67%, then you got to kind of figure out what's the problem, you know, and kind of see why are the levels different. If it's still below 4, you don't have to do anything. If the levels are above 4, okay, and then you have a level of say 5 and 10, okay, if the relative percent difference, if it's greater than 4, is greater than 36%, 10 and 5 would roughly be about 66.6. So that's greater than 36% relative percent difference. They're going to ask for a retest. And why is this all important? The thing is, if you don't put those two tests together, and if you don't test and they're not close, okay, you could either say, hey, you need a radon mitigation, the person's going to have to spend money, or they may be low, the test is inaccurate, and the levels could be higher, and you don't recommend mitigation. So if the relative percent differences are off, usually, the easy one is greater than the lower number. So a 6 and 3, you're going to retest. If it's 5.2 and 4.8, you're okay. The other thing I see inspectors do is they put the devices in 2 different spots. See it all the time. They put one on one side of the basement, one on the other. This side of the basement could be a 3, that could be an 8. So wherever you do it, if you test over there, it's an 8, it's an 8. If you test over there, it's a 3, it's a 3. And sometimes when I come in, I always ask where the inspector or whoever did the test, where they test. So when we do the system, we put it in, we want to try to put it back in that same spot to see what the levels are, or if we have to do some diagnostic testing. So what is radon? Radon is a natural occurring radioactive gas that comes from decaying uranium. It's colorless, odorless, tasteless. You can't see it. It's not tangible. So that's why a lot of people go, oh, I don't believe in all that stuff. But if it's the green gas coming up in the house, they may be more concerned, but you can't see it. It's found in all over the US, all different types of homes, new, old, drafty, well-sealed, with or without basins. There's a big misconception amongst the general population that I don't have a basement, I don't have radon. I've had some very high levels on slab on grade, and I've had lower levels in the basement. We're dealing with alpha particles. So you have alpha radiation, beta radiation, and gamma. Alpha can't penetrate paper. Beta can penetrate paper, and it can't penetrate your hand. Gamma is an X-ray. When you go get an X-ray, that can pass through everything, even concrete. It won't pass through lead. Alpha particles. If you were to go in the basement and hold your breath, you wouldn't be affected by radon. Radon, you can hold your breath and you're not going to be affected by it. As you inhale the alpha particles in the basement, that causes damage to your lung tissue, the DNA, and that's how it can cause cancer. Now, it's usually long-term exposure. It could be high levels, low levels. You could be exposed to 5, and you could, I spend a lot of time in my basement. My house is 12 to 15. It isn't anymore. I'm down there a lot. I could be exposed to it for 10, 15 years. And at that level, 12 or 15, and maybe never develop lung cancer, or you could develop lung cancer. If you smoke, you have a greater chance of developing it. There's also occupational exposures. What else were you exposed to? Did you work in a basement? Did you work in a doctor's office, slab on grade? So, it's really hard to tell. And they estimate between 18 and 21,000 deaths a year. It could be more, it could be less. That's what the EPA estimates. How it enters the home. Everybody knows, if everybody's been in the attic and you feel the air currents going up, there's a stack effect. Hot air, basements under negative pressure, attics positive pressure, stack effect like a chimney. It actually goes from the basement up, out through the attic, out through the vents, and that creates that vacuum. It creates that negative pressure in the basement, hence the reason why we call it sub-slab depressurization. So as that negative pressure is occurring, you can have wind blowing over the house, that karst effect. You could be at the bottom of a mountain, wind blowing, and that can create more negative pressure. That's why they always say don't test during periods of high wind. And talking about high wind, just so you guys know, EPA protocol is if it's windy, gusty wind, and I just had one the other day. It was a few weeks ago. Friday was windy, Saturday was windy, Sunday was windy. The inspector tested for 2 days. And I told the client, you should retest. Because I'm telling you that could definitely raise the radon levels. And EPA says you should test no less than 4 days. Now, I know when we get into the house, sometimes it's better just to say, hey, I don't think it's the right time to test for this reason. Or if you have a continuous monitor like I have, and you only need to use the continuous monitor, you don't have to have two monitors side by side. You can put the monitor in there and set it off to go off in a 24 hours, 48 hours, or just leave it there for 4 or 5 days, which I have, and go pick it up. Unfortunately, sometimes you need that device for other jobs, but it's the right thing to do. And I see guys testing in the wind. That's the first thing when they call me as a mitigator. When did they test? Because usually people say, well, I bought the house. It was low when I bought it. And I say, well, did you do anything to the house? And sometimes they'll say, well, I insulated, I renovated, I did all these things to the house. That could change it. They tighten up the basement, the furnace is in a room, doesn't have a lot of combustion air. So that can change the radon levels. If they don't have any of those, if they didn't renovate and the house isn't unchanged and they tested during those windy conditions, certainly that can raise the levels. Radon and its health effects: exposure to elevated levels. It's no immediate health risk. Usually it's over years. There's no symptoms. I've had people call me up and say, I'm dizzy, I'm lightheaded, I tested the radon. That has nothing to do with it. It's not going to cause those type of symptoms. And it damages the DNA of the lungs and cause lung cancer. And oncologists know it. A lot of times I've been called, somebody has gotten lung cancer. The oncologist asks the wife, have you ever tested your basement? And I've tested it, and sometimes it's been high and sometimes it's been low. How does it come to the house? Cracks in the floors, construction joints, cracks in the walls, gaps in suspended floors, cantilever, in the garage. Sometimes it's cantilevered into the garage. They build a little they build a bookcase and they cantilever it into the garage. Sometimes the gas comes from the garage and enters to the basement. Gaps around service pipes, sewer pipes, newer homes. A lot of times that sewer pipe isn't foamed up. That's open. It can enter through there, through the water pipes. Cavities inside walls, sump pumps, drains in the floor. And a lot of that stuff has to be sealed up when we do mitigate. And obviously you can come through water, radon and water with private wells. So the EPA level for action, they say fix your home if it's 4 or higher. Sometimes when you get that test back and it's at 4, it could have been, it's 3.9 and 4 pretty close. In the wintertime, it could be 3.9, 3.7 could be over 4. And in the summertime, maybe it's below 4. But, 4 is an action level. And I think the reason they use 4 is because as a mitigator, and Stan would know, sometimes it's very challenging to get the levels below 2. And, there's a lot of our mitigations, we're able to get the levels below 2. And sometimes we're only able to get it between 2 and 3.9. It's not a health-based standard. There's always a risk. Even at 1 or 2 picocuries, there's always a risk. And as the EPA said, there is no safe level of radon. And people say to me, can you get it to 0? And the answer is no. There's always going to be a lowest limit of detection, 0.5, 0.3, 0.2. There's always going to be some radon. You can reduce the level lower than 2, but it's going to require more work. And sometimes it's more challenging. And I usually tell the people it's going to require maybe bigger fans, more suction points. It's doable, but it could be a lot more challenging. And most of the time, you usually just see 1 draw point, maybe 2, on a rare occasion 3. And there's an area in Shelton that sometimes I tell everybody 1 to 5 draw points, because it's just it's on ledge, it's on rock, there's stone, the soil is very tight underneath that slab, what makes it hard to draw that gas and create that negative pressure. I hear this all the time. Well, the World Health Organization says 2.7. If you think about it, the EPA says fix your home 4 or higher, consider fixing 2 to 4. So really 2.7 is right in the middle there. So, we don't go by the World Health Organization. We don't go by Canada. I've heard people, oh, Canada's 20. And well, we live in the United States, and the EPA is 4. Mitigation systems, they're effective, and they're called subslab depressurization. We'll get into the different types. They're effective. They're relatively inexpensive. And this is a starting cost. It's a little bit more now. It's gone up a little bit. I'm roughly 1,800 for a single draw point, and then it goes up from there. But, you know, this is close. Go ahead, Jim. Go ahead, Jim. Oh, it is recommended to use a nationally certified mitigation provider. In Connecticut, you have to be, I can't speak for some of the other, you have to be a nationally recognized mitigation provider. I'm with NRSB. There's National Radon Proficiency Program. In Connecticut, you have to be a home improvement contractor as well, and or a certified or a licensed home inspector to test. I mean, you can be nationally certified to test. In order to mitigate in Connecticut, you have to have the home improvement contractor license. This is one of the I just threw this in here. This is a crawl space. This is the actual second draw point, went all the way across the basement. This is, most of the house was crawl space, and then it had, you know, it's like split 50-50. So I ran a pipe all the way across through the finished basement and into the crawl space. Go ahead, Jim. I just threw this in there. If you guys are wondering what the heck did Scott do here, right? You see this pipe on the floor? I'm going to say this really quick, and we're at 7:20. Here's the thing: is there was a radon system put in this house about 25 years ago. The owner of the house fixed jukeboxes. And when I say jukebox, every jukebox you can imagine was in this basement from the 30s to 40s. It was really a cool house. He died of lung cancer. A home inspector out there had reached out to me, and he said, geez, you know, I told him maybe you should test, because the system was put in, they never tested 25 years ago. This was about a year ago. And it came back 22. The system wasn't working. So I went in there, and this was a really tough house. Tight soil below the slab, additions added, the garage was closed off, and then they added another garage. So what I did in a case like this is, sometimes instead of me cutting the ceiling open or running across the ceiling, in this case, I put the first suction point in this room. The other, there was another, right now there's two radon systems going, one in here and one where the original contractor installed 25 years ago. It really didn't budge much. It came down a little bit here, but this room was still running in the 10s. So I ran the pipe across the carpet, and I actually drilled a hole over by the bar, and it really didn't change that much. It was just very tight. The soil was so tight, a lot of ledge. To make a long story short, I ended up doing a lot of diagnostic testing. I left my continuous monitor in there, and he said to me, when he had family over, the radon level shot up where you put it inside the room with all the pinball machines. I know the house is crazy. So it shot. I said, shut up. What do you mean? You opened the door to the outside? He says, no, we opened it to the new garage. I said, oh, new garage. So I moved the machine all the way to the opposite side of the house. It was 18. I ended up putting two systems, one on one side, one on the other. And the levels came down to like in the 2s from the 20s. And I eliminated the one that was originally done. But this guy definitely died of lung cancer. I'm assuming it was because he was in the basement all the time. And it was a sad situation, but we were able to correct that. This right here, I did it. It's wrong, but it's right. And I'll tell you why. The guy who flipped this house, he says, oh, Scott, the radon levels are high. Can you come out? It's all pre-piped. We had to do a pre-pipe. And I said, oh, great. Can I get to the attic? He said, there's no way to get to the attic. I go, what do you mean? It was a cathedral ceiling, ran the pipe all the way through the building. So what other option did I have? I had to stick it down here, and I had to have them sign a waiver. Unfortunately, what am I going to do other than putting it on the outside of the house? So
Scott, that's in the basement?
Yes. And there's a reason why, and a lot of you guys I know are seeing this in new construction. And here's the problem, is the builders don't know anything. Not all of them. They're getting better. The building officials are learning. I'm trying to educate them. The reason you don't want it in the basement, and why it should be an unconditioned attic space, but we could argue about that now with the spray foam, right? Unconditioned attic space, in the garage, in the attic, are outside. Now, here's the problem. If you happen to drill through the wall to hang a nice picture or a mirror and you put a hole in this pipe, where's the radon going to go? It's going to blow into the walls, right? You're going to actually blow radon into the house. If one of the fittings loosens up, you hope it doesn't. I didn't glue. I did this, but the rest of the stuff through the wall, the builder did or the plumber did. And if a fitting breaks away, you're going to blow radon to the house versus it being in the attic and you're sucking all the way up through the house. So if you happen to put a hole in the pipe or drill into it, at least it's sucking up. So, unfortunately, I had no other choice. The levels came down nice. It's not, listen, sometimes you got to do what you got to do. I suggest, the right thing would have been to put it on the outside. But in this case, I'm dealing with this a lot with new construction, really nice homes. This one here, there's a sump pump. You can use a sump pump. That's a Larry Janeski sump pump. Nice job. I like to see that. The covers are sealed up. I actually put more caulk around it. You can put a system in the sump. I try to stay away from it in case there's a problem because the guys who come out and service that sump every year or every 2 years, or it should be every year, they never seal it back up right. And then my pipe is leaking and I got to go back. So this came, I just put it next to it. And obviously it's drawing all through Larry's perimeter drains all through the floor, but you can go into the sump. This is a radon membrane. It's like a 12 mil plastic with a fiberglass mesh. It's an old house. This is what I use. Caulk it to the walls with a masonry caulk. Got to cover the dirt. And then a lot of times you can put a pipe under there and do sub-membrane suction like I have in my house. Go ahead, Jim. This is this is what we see all the time. Why am I 45 away from the I got to get away from the footing, right?
Yeah. And
people always say, well, why do you go along? It would make more sense to go in the middle, right? In some cases, if there's water issues, you have to go in the middle. But the reason why we go close, obviously, it's, if there's any condensation or moisture, it drains down below the floor. But the reason we go there is because in an older home, there's always void spaces, right? Where the footing is, there might be drain tile. There's they didn't compact the soil well. And believe it or not, if you go near that footing, that's a lot of time where the gas comes in that wall footing joint. You suck all the way around and you get a good draw. Obviously, gravel, newer construction is a lot easier to mitigate than an older home. Sometimes older homes, the slabs are rat slabs and they're hollow. This is a manometer, and this is not the radon level. People say to me all the time, this is the radon level, right? No. I can tell you, though, if you see the green all the way up to the top here, 5 inches of water column, it's very tight soil. I can tell if it's new construction or there's gravel, you're probably going to see the level being right here, about a half an inch right here where my arrow is. Can you see that, Jim? Is that on there?
I can see your arrow.
Okay. Yeah. So right about there, if it's real low, it's a half an inch right there where Jim's got the arrow. That tells me air is moving very well. And that's a good thing. We're moving a lot of air. You're going to get a really good draw. You're going to create that negative pressure. And you usually have no issues with newer construction, but there are from time to time. If it's real high, it's tight. I threw this in here. The fans I use, they're nice and easy, quick connects, flip it over, no wire nuts. I like it. It's nice in the winter. Just to show you, this is a system. I'm an aesthetic guy. This is one of mine. I'm big into aesthetics. From the street, you can't see it. I tucked it right up against the chimney. And we'll talk about the disconnects. I know it's later on here. I put a disconnect here. You have to have, I see it all the time. You guys see it all the time. There are contractors that will not put a shutoff outside. They run the conduit inside and they plug it in, and it's not really the code. There's really no radon police out there, but there has to be some sort of disconnect, whether it's a plug, whether it's a switch, close to the fan. And this way, if I service it and if I trip the power, if I do that and if I don't shut that off and I can't get inside, we've all done a GFI test outside, right? It's on the refrigerator inside. Well, this way I could shut the power off, change the fan, and turn it back on. If I try to do it live and I trip a circuit in there and the people aren't home and it happens to be on, somebody put it on a refrigerator circuit, you could have problems. So, you want to be able to shut the power off for safety too as well. Nobody does this. I shouldn't say that. I very seldom see it. And if I see it, it's because I do it. These are fire collars. So when you see these pipes, this is me. I like to do it right. This is a fire collar. There's one on, if I go through the rim, I put one on the inside, one on the outside. There's fire caulk in here. If there's a fire and this melts in the garage, this is in the garage. This will close up so the fire doesn't spread. That is by code. But usually what you see is the pipe through the ceiling, pipe through the wall, and nobody does nothing. Okay, we'll look at mitigating radon is an effort to remove the radon before it enters the home. There are several types of radon mitigation systems which can reduce the radon levels. The most common is sub-slab. That's the best method, no matter what. For the most part, sub-slab. That means you're drilling a hole through the floor, putting a pipe in the floor, fan outside, powering up the fan, and you're creating negative pressure below that floor slab. So there's more positive pressure. Go back to that. There's more positive pressure in the basement to try to help keep that more positive here. Remember, the basement's under negative pressure. If you make more negative pressure below the slab and more positive, it'll push the radon down, and you're also drawing it out. That's the best. And it's not just for radon. They can use it for oil spills, other if somebody used chemicals back in the day, liquid 7, chloridane. We have them being used here in Milford because of the old electrical plant and all the chemicals that are in the ground. Drain tile suction. A lot of times I'll connect into Larry Janeski's system or another company's system right in, and that's perfect. That's like you're going to suck all the way around the basement as long as that system is a closed system, which a lot of times it's not. Sump hole suction, you can do that. It's a big hole already. A lot of times gravel, you can get a good draw. The only problem is that if somebody opens it, they don't seal it back up. Now it's no longer creating that negative pressure. Block wall. Sometimes the gas comes up the block wall. You actually have to put a suction point in the block wall and suck from that block wall. I've had to do it a few times, but usually you're okay with below the floor slab. You've got submembrane. Remember that plastic I showed you? Sometimes you cover the crawl space with plastic, and I put a perforated pipe 2-inch because you're going to move a lot of air, and I'll drill holes in it and I'll stick it underneath, tape it off, and now you'll have sub slab below the concrete floor and under the membrane. And you'll have two, like my house, I have them in both crawl spaces under the plastic membrane and in the main part of the basement. So I have 3 suction points. Active crawl space depressurization. That would be where you would close off the crawl space and you put the pipe in there. The only problem with that is sometimes you're bringing outside air, and if there's plumbing pipes in there, pipes can freeze. I've never really done that, but it can be done. And why not just put a membrane down or go into the floor slab if it's a concrete slab, but it can be done. Room pressurization. Some guy sent me a photo today. It looks like his radon fan is upside down. It's been like that for 27 years. And I'm curious to go see what's going on there, because maybe it's pressurizing below the floor and pushing the gas out. Maybe somebody messed with it and flipped it upside down. I don't even know if it's working. He says it's making noise. Heat recovery ventilation. If you haven't seen one of these before, they do work, but I will tell you, if the radon levels are super high, where I've put these in is farmhouses, multiple crawl spaces you can't get into. There's duck in the way, there's dirt. You can't get the levels down through traditional sub-slab depressurization. You can actually do an HRV, bringing in fresh air from the outside. Air in, air out. You're just bringing in fresh air. And there's a lot of issues with those. I mean, you got to keep the filters clean. Most homeowners don't. Sometimes it'll bring in cold air. It should be heated, but a lot of times I've actually had a customer, it didn't come down all the way. And I ended up, it was a monolithic slab. I ended up getting draw points towards the center and around, and I was able to get it down and get rid of that for the customer. and passive sub slab is what we're seeing in new construction. All new construction as of 2016 has to have a passive system in. And I'll tell you, and we've all seen it as inspectors, sometimes they just stub the pipe up. Sometimes they put the pipe in a room that's in the front of the house. A lot of times, like that house that you saw before, they run it all the way up and they put it in the attic and out through a cathedral vaulted ceiling. You can't get to it in the attic. So they're getting better. The building officials are getting better. And I try to educate them as best I can. So it makes my life easier in the future. Let's see. Fan must be installed on the exterior, in the attic, or in the garage, never in or below a living space. Now, this one in the attic, go back to that, Jim. This one here in the garage technically is wrong. And it looks, that should be in the attic of the garage. This one in the basement, again, it should be in the attic. This is in the attic. This is fine. This is outside. And just look at this picture up here where it's on the outside. That pipe should be about 10 feet from that window, 9 feet, 6 inches. Sometimes you get as far away as you can. If it's not 10 feet away, if it's below the window, 10 feet away. Above the window, at least 2 feet above the window. So if the window is here, the pipe has to be 2 feet above it, minimal. If it's below the window, it has to be 10 feet away. Who came up with that? Is 9 feet going to make a difference? They just don't want the gas to go back in. I would turn that pipe and maybe vent it back this way if that wasn't quite 10 feet. Go ahead, Jim.
What about this? All right.
This one, there has to be a method of disconnecting the thing. I wouldn't have wired it this way. I would have just kind of went straight through, but brick is a little more challenging. I would have put that box lower so you don't see all this stuff, but it's fine. Go ahead. Back in the day, the company's not in business anymore, or the two are not in business. They used to use thin wall pipe, which is fine. You can use it, but you're not supposed to use thin wall pipe outside where it's cold, because we all see the drainage pipes that all crack, they break, the sun breaks them down. It's supposed to be Schedule 40, which is plumbing pipe on the exterior and areas where it's subject to abuse. If you're watching this and you're not watching it during the live seminar, viewing code is RW8263, RW8263. The system, it has to be labeled. If I do multiple draw points, you guys probably don't see it. I do it. That pipe running through the basement, it will say radon, 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 radon. Even it's written with a magic marker. If I do new construction and I go inside the wall, I'll write radon, radon, radon. And the reason is, if somebody opens the wall to do renovations, you just don't want them to think it's a plumbing pipe and tie into it. Has it happened before? I'm sure it has. You have to have a manometer on there. That little tube that's sticking in the pipe up there, if you ever see that pulled out, if it looks like a U and not a backwards J or a J, sometimes that tube is pulled out on the inspection. So you're going, hey, this thing isn't working. Check the tube. Check the tube, make sure that tube is in. If the tube pulled out, stick it back in. And if you see a change and it matches the number on the side, if it says looks like it's, if it's 2.3 and it says 2.3, you're good. It's working. That's just to let the homeowner know that the system's working. This system's fine. Would have been nice to get closer to the chimney, but who knows? There could be duct work.
Hey, Scott, question for you. I know we're going to be short on time, but a lot of times I'll see them underneath the soffit.
Wrong.
Right.
It just stopped under the soffit? Yeah, that's no good.
Could that actually draw radon back into the house through the attic?
Yeah. Hey, okay. Soffit, air in, air out, right? Soffit to ridge. Yeah, absolutely. Okay. 12 to 18 inches above the roof line. You can make the argument if it's over here by the gable vent, it's possible air could get sucked in. I'm always cautious about that. I try to be careful, but you're at the mercy of the house sometimes. Go ahead, Jim. On here, it's going to say date of installation, what the initial vacuum pressure is. This one, it's very low. That tells me it's moving a lot of air. Estimated cost, it's like a light bulb. $75 a year. Most people never know it's on or off. It doesn't really draw that much, 1.5 amps. If it's on a circuit, I wire it to the panel a lot of times with its own separate breaker. If I can't put it on a separate breaker, I pigtail it. So, I don't want to be a hypocrite as a home inspector and say no double taps, but maybe I'll find a basement outlet or two and we'll wire it into that. And you got to make sure you label it. Okay, things to note during a home inspection. This is important. If you think the system is not working, check the following. Make sure the switch is on. I can't tell you how many times I get a call. My home inspector said it's not working and the switch is off. So I tell people over the phone, check the switch, check the tube, check the breaker. If all that's good, I'll come out, because if I come out, I got to charge a service call. Make sure the breaker's good. We all know how to check for the breaker. The other thing is make sure that tube is in. We talked about that. Go ahead, Jim. What I'm showing here, if you think it's not working, put your ear against it. Put your hand on it. You guys all have done enough inspections. You can hear them. The one on my house is real loud. I put a stronger one on there. This has no disconnect on it. If you notice that, the conduit just goes right through the wall. You're not supposed to do that. See it all the time. Still see it. It's not the way you're supposed to have a mechanical disconnect, just like a condenser or any other thing that's outside. It has a way to shut it off so you can kill the power. Go ahead, Jim. This is multiple draw points. This is one of my houses. This house had three. This basement was huge, and I just ran pipe all over. You can see the plumbing pipe next to it. Go ahead. Same picture we saw before. Go ahead, Jim. This is going back to what Jim. This is actually a slab on grade, and I've dug down below the ground and go underneath the house, through the wall, and then under the slab. And instead of going through the floor, I'm going through the wall and under the slab. The problem with this one is this is what Jim was talking. This is not under the soffit, but this is way too low. Minimum 10 feet above grade if it's a ranch. But in this case, this pipe should have went all the way up and over the roof, whether it's a gable end or, you can't leave it like that under the soffit. We all see that. They get lazy. They go on a gable end. They go up a length and a half. If there's no windows, and they just put a 90 on it. That's really... Is it a huge deal? Is it the end of the world? No, but it's not right. It's got. Is your toilet pipe vent there? You're mining radon, and it could be thousands of pica curies coming out of that vent. You want it as high as you can. Go ahead.
Scott, one other question. At the top here, I'm seeing a lot of times that it's like a U-turn. It'll be like a U. It comes back down. Is that allowed?
That's a gooseneck for water. You got to have that, so you can't have rainwater go into it, because the radon and water system, which we'll get to, I know we're.
Yep.
Go ahead.
Okay. Yep. Go ahead.
Passive radon system. There you go. We talked about that. It's required. New construction. Go out through the roof, look like a plumbing vent. Sometimes you guys will get up on the roof or up to it and go, "What the hell? What's all these pipes sticking out?" One of them, if it's newer, it could be a radon pipe. Go ahead. Viewing code. If you're watching this at home and not part of tonight's presentation, WR9048, WR9048. All right. This is a typical fan. I use different fans, but I took this one off today, so ironically I saw it. So this is a Radon Away RP145. It's comparable. This is pretty much the type of fan that I use. I use another company fan, Festa Radon. I do like it, but they're both good fans. I use these for years. If you notice this fan is, a medium air velocity. You use this newer construction, maybe 1,800, 2,200, 2,500, maybe 3,000 square foot home with a lot of gravel on the floor slab. It's 4-inch in and 4-inch in, 4-inch out. Two types of fans that I use. One that creates a lot of suction and one that moves more air. And then you can get a higher suction fan, and you can get ones that create more suction. So you can get a higher suction fan, or if you got a school, you can get a 6-in, 6-out, moves a lot more air, and it just depends. And sometimes you have to do some field testing. If you do this long enough, I get a pretty good feel when I go to a house. And sometimes you got to change the fan. Go ahead, Jim. Sometimes the fan that we put in, sometimes you got to go stronger. You have to put a stronger fan in, And, sometimes you get a call back. I just had one where I put in one draw point. I did a suction fan, 3-inch, 3 out, 3-inch pipe is usually what we use, 3-inch pipe. And it came back 4. So I had to run another draw point all the way across over by the crawl space. And I told her that. I knew her. So I tried to save her a little bit of money. And then it came down to like 1.7 after that second. So sometimes, I got 15 minutes, so we're good. Sometimes it's just a matter of changing the fan, stronger, higher suction, one moves more air, and sometimes it's doing additional suction points. But, in a real estate transaction, people want the most cost-effective to get in and out and sell it. Just get it below 4. That's all I care about. Me, I want to try to get it as low as I can. And there are some people that go, Scott, I don't care what it costs. I want it below 2. Okay, let's try this first. And a lot of times we get below 2. First shot, 1 draw point, 1 suction point. And then sometimes we have to do stronger fans and more draw points. Radon in water. Radon in water. Go ahead. We talked about that already. I don't know how I got back in there. We talked about how it comes in. Go ahead. So most of radon inside a home comes from the soil below the home. As decaying uranium breaks down, radon gas forms and seeps into the house. Radon from soil can get into any type of building, homes, offices, schools, and build up to high levels in the air inside the building. Radon gas can also dissolve and accumulate in water from underground sources called groundwater, well water, private wells. When water that contains radon is used in the home for showering, washing dishes, and cooking, radon gas escapes from the water and goes into the air. It is similar to carbonated soda drinks, where carbon dioxide is dissolved in the soda and released when you open the bottle. Some radon also stays in the water. So the most concern for radon in water is showering. And just to give you an example, right? The EPA has no set guidelines. They're looking at 4,000 picocuries in water. Connecticut, as you guys know, Connecticut sets it at 5,000. Massachusetts, correct me if I'm wrong, Gary, are you guys 4,000 or 3,000? 4,000, right? So each state can set the level. Just so you know, 1 picocurie of air is equivalent to 10,000 water. So when you get the level back and it's 5,000 or 8,000 people they're panicked, oh my God, it's 1 to 10. So 1 picocurie of air to 10,000 picocuries of water. If you have 10,000 picocuries of water and you take roughly a 10-minute shower, depending on the gallons per minute, depending on the bathroom ventilation, window open or close, you could have roughly 30 to 40 picocuries in air. They've tested it, and you can have. So standing there, you're inhaling all that radon, and that's where it becomes a problem. If you don't use any water, it's not an issue. But flushing toilets, dishwasher, everything, that radon escapes, especially with the warmer water. Go ahead, Jim. It's not a problem when it comes from lakes, public water supply, because all that radon gas just dissipates, and it's not an issue. They do monitor it, and it's not an issue. That's why we don't really test when we don't test at all as far as city water.
Through this, I think, radon. Right.
Yeah, there's most of the deaths are from air, not so much ingesting. They do say that could cause stomach cancer, but it's very low. Do they know how much? They estimate 18 to 21,000 deaths a year. Stomach cancer and all other internal organ cancers is usually very low from ingesting radon. So about 1 to 2%. Based on the National Academy of Science, EPA estimates that radon in drinking water causes about 168 cancer deaths per year, 89% from lung cancer caused by breathing radon released into indoor air from water, and 11% from stomach cancer caused by consuming water containing radon. Go ahead, Jim. So 1 to 10, go ahead. One
Yeah,
piping period to
you're good
10.
there.
Go ahead. Not all drinking water contains radon. We talked about city versus
Yeah.
private wells. You should tell your clients to test. You know, we test for a whole bunch of things. Radon water is a good thing to test for and to add on to your.
Also, Scott, the remediation can be much more expensive in the water than it can in the air, right?
It could be
And
anywhere
then,
from 2,000 to 7,000.
and then let me ask you a question. If you get radon in the water, let's say it comes back really high, it's 20,000 picocuries, and that puts 2 in the air, and your air comes back, say 3.5. Would you just remediate in the water and you don't have to
Right.
remediate in the air?
Well, here, good question. Most of the time, if your radon levels are high in a basement, it's a result of coming from the earth, right? From the ground, from the soil, from the rock. It's not
Right.
necessarily coming from the water. And if you have a shower, if you have a shower in the basement and people use that shower, like I have a shower in my basement, if you're testing the air and somebody's using the shower and the laundry all the time with well water, that could add to the air. Okay. So a lot of times when I test, I tell them, do you use that shower? No, nobody uses that. Okay, you're fine. They're not really using that laundry that much. You're not testing near it. So you test the air, test the water. So you could have high air, low water. You could have high water, depends how deep the well is, and low air, or they both could be high. So yes, water can contribute to the air.
Okay.
But it just depends. If it's a basement that's unfinished and there's nothing being used down there, it's not going to affect it. It could.
You also have showers on the first floor.
It could. I mean, you could get, you could get, if the levels are high in the water, it could affect. But that once you shut the water off, the fan's going, the window's open, the levels are going to drop. I want to try to get to the bubbler. We talked about. Connecticut is, they're looking to propose a 4,000 EPA right now. It's only air. There's no water.
Okay.
But Connecticut's at 5,000. And just to let you know, if it's over 5,000, 5 to 10, the state of Connecticut is recommending you can, between 5 and 10, I would use a carbon system, 10 and over aeration system. People certainly at 8, 9,000, 6,000 would like to choose an aeration system over carbon. And there's pros and cons to both. If you have a private well, EPA recommends testing your drinking water for radon. Call the Safe Drinking Water Hotline. That's the number, which can provide phone numbers for your state laboratory certification office. We work with a local lab. Gary works a lab, I'm sure, up in Mass. Your state laboratory certification office or state radon office can direct you to laboratories which may be able to test your drinking water for radon. If you have a private well, the EPA recommends testing your water for radon. Purchase a radon and water test kit, collect a sample of your water with no air in the sample jar. We'll talk about sampling. Ensure the water sample is collected from a source in your home where the water coming out is not aerated or treated by water softener of reverse osmosis system. Let me just kind of talk about that real quick. You have to take the aerator off. If you're doing a yield and recovery or flow test, you've run enough water. You want to, if the house is being used, they're using water, right? We all agree. If the house is vacant, you got to run the water for a while to try to get that sample deep in the well. I will tell you, reverse osmosis, I mean, what are you going to do? Unless it's a raw sample, we test all of our stuff after the softener, the neutralizer, the RO system. Generally, you're probably not taking it from it because it's either under the sink and there's a separate little spout for it. But, they're thinking that the water softener can agitate it, but it is what it is. I mean, you're not going to shut the softener off, and you got to be careful if you're going to take a raw sample from the tank that if you start messing with the faucet on the tank there, that it could leak, and you got to be careful. I like to run the water during my home inspection. If I'm not doing a home inspection, I'll run it for at least 15 minutes, take the aerator off. This is the way I do it. I see guys do it all different ways. I take a bucket or a bowl and listen, if you're agitating the water, the radon's going to come out. So you fill the bowl up, you put it under the sink, you run it, you fill it up real slow, you fill up the bowl, drop the bowl, and submerge the vial. Make sure there's no air bubbles in it. If you're going to try to do it off the faucet, there's a lot of ways to do it, but if you're agitating it, you forget to take the aerator off, which people have done, aerator, it's going to aerate the water, and you're not going to get an accurate test. And check.
What do if you can't take the aerator off? If it's one of these,
Good question, Jim. Use a tub.
Okay, use the tub.
Tub has nothing on it. That's what I do. And,
right.
and a lot of times, I take pliers and it's hard to get off. I use the tub. If it doesn't come off easy, and I have extra in my van in case I break them, we've all broke them. If you haven't, you're lucky. And health department set an advisory level in water 4,000. Again, Connecticut's 5,000. EPA recommends fixing it around 4,000. That's proposed, but Connecticut, where we are, is 5,000. How to mitigate radon water? There's a GAC system, granular activated carbon. The way this works, it works. You have charcoal in there, right? And it doesn't work. It's not absorbing the radon, right? If you absorb something, it kind of actually goes into whatever it's absorbing. Sponge, it soaks it up. This works by adsorbing, which is different. The radon molecules fill in between that carbon inside that tank, and as it fills up, then obviously it's no longer effective anymore. And these tanks, depending on how much, these run anywhere from now you're looking about to install one of these, plumbing, piping, and all that, about $2,000, $2,500. It should be changed every year, about $400 to $500 for the media. If it's not changed in about 7 years, 8 years, that can become radioactive. It will become radioactive. And what I usually do is shut them off, let them sit. That radon will decay and then come back and change it. And a lot of times it's packed so tight, it's really hard to get a lot of that media out. But
hey, Scott, we have a question.
Sure, go ahead.
If the radon is high in the water, a shower, let's say, is 20 to 30 minutes of exposure. Isn't radon all about hours and years of exposure? Meaning, if the radon in water, is the radon in water really affecting the air in the long run?
Good question. Well, I mean, if you're showering, if you're showering every day, just say at 10,000, not 10, that's 10,000, right? That's one equivalent to one in air, and you're showering, you take a 10, 20, we all take a half-hour shower, you could have 30, 40, 50 picocuries that you're breathing right there at the shower head.
Every day, maybe sometimes
every day, all the time you're taking a shower. So to some degree, that's probably even worse than being exposed to radon in the basement at 5, 6, 7, 8, 9, 10. So it is a high risk, and certainly there's still a risk unless it's less than 300 picocuries. There's still a risk, even if you're at 3,000 picocuries in water. There's still a risk there. That's why some people will want a system put in. They just want it as low as it can go. And a lot of times, once the system's in, the best system out there is an aeration system. So basically, with an aeration system, how it works: air comes in. It comes in from the well itself. Oh no, this is the granule. I'm sorry, this is the carbon one. So carbon comes in and it works on a process it basically adsorbs, fills up those different areas between the carbon, and then it's purified water. The good thing about carbon is carbon also takes out other impurities. So that filter will get clogged up, not just with radon, but if you have, lead, any other impurities that come out of that well, that filter will work. I mean, carbon is a great filter. I have it to take out chlorine in my house, and I have city water. So it takes out a lot of other stuff out of the well, but it also clogs it up. That's why it's good to change it once a year. The best, there's no electricity. It's passive. If it gets clogged, the flow slows down. There could be radiation buildup over a certain amount of years if the people never change it. Some people leave them in there and they never change them, or there's 2 tanks and they switch them, and they'll switch one out every other year. The tandem tanks that you see, it looks like a big scuba tank, and they also look like the tank that the softener has, and also looks like the pH tank, very similar. 9 by 48 inches or 10 by 54 inches, different heights. But it's just water in, water out. There's a bypass on top. If you see a metered head or anything on that, it's probably something else. Aeration is the best method. You're looking at about 80 to 85% removal radon with a carbon system. Aeration, you're looking at anywhere from 90 to 90, 99, 95 to 99% removal. How it works in this, if you go to the next one, Jim, I think it's in there. I'm not sure. Can't remember.
Yep.
If you look, yeah, this is a aerator. That one's a bubbler. So contaminated water comes in from the well, contaminated with radon. There's a fan on top, and then there's a diffuser inside. The best way to explain it is you put in a straw in a glass, you blow out the straw, and you're agitating the water. When you're agitating that water, it releases the gas. So when the water comes in from the well, okay, it'll start filling up the tank as the water is getting used. It starts to fill up. The fan kicks on, agitates the water. The gas is released through that vent that Jim saw outside with the gooseneck on it. You got to have a gooseneck on it so this fan isn't on all the time. So it's not blowing constantly like a radon fan. That's why radon fans could be wide open. Everybody goes, don't you put a cover on it? And the answer is no. You want the air. The more turns in 90s, the slower the airflow. But in this case, you don't want rainwater getting in there and contaminating. So it's agitated. There's a float switch in there. That float switch, as it rises, it shuts off. If it doesn't shut off, it's going to overflow. If it overflows, there's a safety switch on top that senses water overflow, and it shuts down the water coming into the unit. But whatever's in that unit, it may pump out if you have a leak, 25 gallons, 40 gallons. This actually isn't a GAC. This is a softener, and it almost looks like a neutralizer. Cost of radon and water mitigation. Again, $2,500 to $7,000. There's different size units depending, big house, small house. You guys see these are bubblers. There's a bubbler junior, there's bubbler seniors, a little bit bigger. They hold 25 gallons to 40 gallons. Oh, go back a sec, Jim. Right here. So this is the blower. There's the diffuser that agitates the water under here. This is the control. This is the burst buster. If water overflows, there's a sensor on here, and there's another one on top. This is the pump control pressure switch, just like a well tank. There's the gauge. It usually runs 40 to, anywhere between 45, 50 to 70. Keeps this, if you have bad pressure, this will help with the pressure in the house. The difference
is that blue tank expansion?
You gotta have an expansion tank. Yeah, and that does get waterlogged. So you guys can test it, ping it with your hand, and then they're constantly getting waterlogged. The good thing about this is there's no radon buildup. You open that tank, there's no radon in there. The carbon system can build up radon. They get dirty. You got to change the media. This one should be cleaned once a year. So if you go and do an inspection, and I know we're a little bit over, if you do an inspection, if there's no service stickers on here, recommend to your client, hey, it should, bacteria can build up there. It's always recommend to have the tank disinfected and cleaned. Sometimes, I change the, there's a spring inside the solenoid. There's things that you can do to this. The problem is this is mechanical. It can break down, but there is bypass. There is a bypass on everything. You can bypass everything: softeners, neutralizers, bubblers. There's two arrows in the back, and if they're pointing together, it's in bypass. One in, one out, it's working. If you don't hear this turn on, when you're running the water, you should hear the fan kick on. You should hear the pump kick on. If you don't hear it, something's wrong with it. It's not being used, or it's for whatever reason, and maybe it's in bypass, maybe it's not working. But always suggest to your clients to have them serviced. We all do. Have them serviced, just like the other water treatment equipment. And test the radon. Test the radon in water, and I guarantee if this thing is working, it will radon in an aeration system. It will always work as long as this system is functioning. You'll never have a high level radon unless there's a problem with this machine. It's not operating. Carbon, if it's been in there a long time, the levels could come back high. And there are times that they put the carbon system in when the level was maybe 8,000 and the house was vacant. The inspector got 8,000, and then they move in and the levels can change because now there's more water being used deeper from the aquifer and the well. And a lot of times everything's perfect and the levels are still high with that carbon system. And sometimes they switch over. This is the best system for radon and water. Yeah.
Scott, I got a question. How often do you service radon and air mitigation systems?
Great question. I think Stan and I were joking about this is never until it fails. You can always tell, people call and say the best way to service it is testing every 2 years. So I tell every client, test it every 2 years. There's really not much you can do to it. I mean, if the fan is making noise, if it's either going to work or not work. And sometimes when it's on its way out, you'll hear it'll be whistling loud, winding. You hear the bearings and everything. But if a client wants me to service it, I'll come out and I'll suggest testing it, and I'll look it over and make sure there's no leak around the pipes. Make sure that everything outside the pipes are tight, nothing's loose. I mean, I can service it, but generally once we put it in, it's test every 2 years, and these guys should last anywhere from 8 to 15 years. And the one in this house that I'm going to go look at that's upside down has been there 27 plus years, but it's in the garage. But, maybe that's something that we should do in the future is offer a service to it. People a lot of times I just tell them, make sure you test every 2 years, but there's not a lot, there's not a lot to that fan. They work, they don't work. You can't pull them apart. You can't replace anything. It works or it doesn't work. And the thing, listen, guys, if it doesn't work, don't test unless the client says, hey, test, I want to know what the baseline is. If you go there and it's not working, just make a recommendation. I know you'll lose money, or you can say, hey, have it fixed and I'll come back and test. And if you want to add a little bit more money to it, great. And go back and do a test. Or I'll tell people, just have them come back and test it, or I can test it. But, if it's not working, don't test it. And again, 4 days for wind, high winds, nor'easter, you may not want to test. You may want to come back, or at least minimal 4 days. I see that all the time. Don't separate the devices, keep them together. And those are some of the things. Check to make sure that the fan is running. It's above the roof, away from a window. If you ever have any questions, I feel like this could go on for 2 hours. There's so much I would like to break it down. Right. But if you guys have any questions, guys call me all the time. Send me a picture. Something doesn't look right. There's a bulge. They'll say, oh, there's a bulge on the fan. Sometimes the fern coat gets a little crooked. It's not going to affect. It shouldn't affect the fan. But if you have any problems, call me. I'll be glad to help you.
Scott, thank you very much. This was really, really informative. We're going to be if you missed any of this or you want to see it again, this will be put up on our website tomorrow. Just to remind our Connecticut inspectors that we have our Connecticut Law Seminar Monday, January 5th and 6th. That is going to be from 7 to 8:30 both days. Then we have mobile homes, January 20th, February 3rd, combustion air and venting safety. And as always, if there is some topic you would like us to cover that you feel is important or that just interests you, please feel free to reach out to the email. You can see it on the screen, or just use our contact form on our website. And thank you for attending tonight. It was very, very informative. Great job, Scott. Thank you.
Real quick, guys, the date on this fan is on the side. On the other fans, they're on top. If you want to know the date, sometimes you can't read them, but it's on the side. That's all. Have a nice night.
Okay, folks.